today we will be starting our unit. This comes from chapter 6 in the book. Today we're going to be looking at polygon angle sum theorems. There are two different theorems in this section. One to find the sum of the measures of the interior angles, and then also to find the sum of the measures of the exterior angles. Today we're going to focus just on those interior angles of a polygon. So the first thing that we glued into our interactive notebooks is this chart, which will be helpful to you in this unit, which gives you the names of pretty common polygons. So you see their names, and then in the left side you see the number of sides that they have. If they have that many sides, they also have that same number of angles. Okay. So those polygons, again, these are common polygon names that you want to become familiar with. You will have this chart in your interactive notebook that you'll be able to use on our chapter test and quizzes, but it's not something that you would have on any kind of standardized testing that you do. Okay. And you will see those names being used when you take the pre-ACT or ACT tests. So just a good idea to study those polygon names. The next page in your interactive notebook, going to be looking at, as I mentioned before, the interior angles, so the top two flaps in your book. On the left-hand side, it says the sum of the measures of the interior angles of a convex polygon is, and then you need to write in this n minus 2 times 180. Okay, so that's what you need to write in. Okay, so the quantity n minus 2, where n is the number of sides or number of angles, so n minus 2 times 180. When we read that first statement, they talk about this idea of a convex polygon. So I want to explain that a little bit. Everything that we're going to be working with when we apply these rules are convex polygons, which again are typically what we would think of when we think of a polygon. So if we're thinking about a five-sided polygon, a pentagon, we would typically think of something that looks something like that. That is a convex polygon. The opposite of a convex polygon is a concave polygon. And a concave polygon simply means that one or more of the vertices, these corners, have caved in towards the middle. So a concave pentagon may look like that. Still five sides, okay, but we see something caving in towards the center. Okay, so that's a concave polygon. We're always going to be working with these convex polygons where all of our corners point towards the outside. So again, to find the sum of the measures of the interior angles of a convex polygon, we're taking the number of sides minus 2 and then multiplying that by 180. And the way they came up with that formula is to take this convex polygon, choose any one vertex, and then go to the other vertex to make triangles. So when I do that, this convex pentagon, five-sided figure, has been broken into 3 separate triangles. And what do we know about the interior angles of a triangle? They add up to 180. So each one of these triangles, the angles add up to 180. And if we combine the three triangles, it is forming the interior angles of that pentagon. So 5 sides gave us 3 triangles. So that's why we're taking the number of sides, which in this example would be 5, minus 2 would give us 3. We're going to take 3 times 180. So with this example, it says to find the sum of the measures of the interior angles of a convex dodecagon. So a dodecagon has how many sides?
Oh, do you want to fix
Okay, guys, let's quit messing around and focus up here, please. Okay. So n is 12, so then we need to plug that into the formula. Okay. So again, you need to plug it in directly into the formula. So 12 minus 2 times 180. So 12 minus 2 gives us 10. And 10 times 180 is 1,800. Okay. So you are going to get large numbers. Okay. We will not be using calculators in this unit. Okay. You will be doing that multiplication process. But again, you will need to show that work. So plug the numbers into the formula. So 12 minus 2 times 180, then work it out. So that's to find the sum. Then on the next flap, we're going to find each interior angle for a regular n-gon. Okay? N-gon, which means simply that we can put any number of sides. We could have just said the word polygon. When you see that word regular, regular means that all of the angles are the same size. Okay? In just a regular polygon or a normal polygon, okay, polygons don't have to have the same measures. If they tell us it's a regular polygon, then each one of the angles is the same. So if we know how to find the sum of the angles, n minus 2 times 180, to find each one, we're just going to divide it by the number of sides. Because that amount, total amount, the sum is being divided equally. So the example here says to find the measure of each interior angle of a regular 20-gon. So that tells us what our n is. Our n is equal to 20. So now we're going to plug that information into our formula. So we're going to have 20 minus 2 times 180. And then we're going to divide it by 20. Okay. Common mistake that we see when we get lazy and we don't think we want to plug everything into the formula is we think we want to do that n minus 2 in our head and just put 18 times 180. But what often happens then, because we write 18 here in the numerator, we also use 18 in the denominator, which is not correct. So again, you want to plug everything into the original formula, and then we need to work it out. So what would we want to do to work this problem out? Okay, so if we think of our order of operations, we would do our parentheses first. So 20 minus 2 is going to give us 18. So then what would I do next? Multiply by 180. Okay, if I take that 0 off of 180, I see 18. What is 18 squared? I'm taking 18 times 18, I'm squaring 18, 324. And then we just attach the 0 back on the end. I'm going to divide that by the 20 in the denominator. So now I need to divide that out or try to simplify it. First thing I can do is divide by 10, which gets rid of a 0 on each end. So then I have 324 divided by 2. So what's half of 324? 162. Half of 300 is 150. Half of 24 is 12. 150 plus 12 is 162. Okay. So that's what we come up with for our answer. We could have also, in the original problem, we could have went ahead and divided by 10. Okay. Same kind of thing. We still took the 18 times 18 and got 324. We just attached the 0, cross those zeros off at the end. Okay. So sometimes there's different things that you can do to help simplify that process. So each angle in a 20-gon is going to have a measure of 162. So that's our focus today. Tomorrow we will work with the exterior angles. Today we're working with the interior. Okay? So sum of the interior angles is n minus 2 times 180. We're looking for each individual angle in a regular polygon. Then we just take that sum and divide it by the number of sides. So again, key thing as you work these in your workbook is you're going to be writing this original equation down. So plugging the numbers in and then doing those calculations.